Greetings everyone. I'm Suhas Reddy Bhupati and I'm going to present my course term project done on safety equipment detection on construction site using object detection model. So my main objectives for the project are to develop an object detection model using Python and using YOLO V8 model for identifying safety equipment detection on the construction sites. That is to enhance safety monitoring system using advanced artificial intelligence and machine learning techniques. So it's also my project aims to improve PPE compliance and reduce accidents through automated detection model, demonstrating the effectiveness of YOLO V8, which is you only look once V8 model in real-time safety monitoring. So coming to the construction site hazards, on the construction sites, generally many accidents and injuries happens on the daily basis. In order to avoid them, strict safety measures are very important, and workers face risks from equipments, machinery, and environmental conditions on daily basis. So in order to comply with the safety standards, it is critical to minimize the accidents on the site, and generally if it is done by the humans over on due to the oversight, it leads to significant safety risks and damages. So we need some kind of automation in the construction sector to detect the safety equipment on the workers. So that is the our project main motto, and safety measures such as wearing PPE are very important. And the safety equipment such as hard hats, vests are very important but difficult to monitor on a daily basis manually. So what we do in our project is we introduce artificial intelligence and machine learning in order to reduce the labor intensive and process which leads to mistakes majority of the times. So AI powered object detection model, it will be very useful in real-time compliance monitoring. I have used my YOLO V8 model, which is robust and efficient detection, which has efficient detection capabilities for construction. Integration of artificial intelligence can improve response times for the safety accidents. Advanced models like YOLO V8 can detect non-compliance, that is hard hats, vests, and many other safety equipments, and unauthorized personnel in the real time, ensuring safety. Coming to the data set I have used, I have basically categorized the objects into 10 categories. Examples like hard hats, masks, safety vests, machinery, safety cones, etc. And I have subdivided them into training, validation, and testing sets. So, coming to the class distribution, I have a balanced representation ensuring through pre-processing, visual analysis of class distribution graphs to check for any imbalances that might happen during the pre-processing phase. The image properties I have used is 640 into 640 pixels. So I have used variability in dimensions addressing with resizing and normalization. I have also enhanced dataset diversity through data augmentation and simulation data. Um, Coming to the hardware that I have used is i7 1260p CPU and 16 GB RAM for efficient computation and smoother processing of the images. I have used Google Colab for as a tool and a platform for cloud-based training for the model, and used Python programming environment to write the code, and I have used libraries such as PIP. And coming to the data storage and access, I have used Google Drive to ensure the smooth and seamless data access. And I have also used such development tools such as Jupyter Notebook for structured experimentation. And I have also version control with Git for collaboration and reproducibility. Coming to the data, I have collected the images from public sources as well as some artificial sources, ensure diversity in lighting, angles, and object positioning, so that we will be having diversity of images to ensure that our model has good accuracy and precision in uh, testing all kinds of images. So I have labeled the images into basic 10 categories as talked in the data section. And I have emphasized non-compliances casing such as missing PPE, missing wears for more comfort in detecting the s- safety equipment. Coming to the pre-processing section, I have resized the images to meet YOLO V8 input requirements and resized the images, all of them to 640 to 640 pixels and applied normalization for consistent pixel intensity. Coming to data augmentation techniques such as flipping and rotations, I have done them to increase the variability in the images. These are some sample images that I have collected from internet sources and some public sources. So, coming to the model initialization, I have preloaded YOLO VI weights for transfer learning, configured training parameters including epoch, batch size, and learning rates before, and utilized GPU acceleration in Google Colab for efficient training. So I conducted iterative training with periodic validation to monitor the performance, saved optimized models, wait for deployment also. And I have calculated the precision. The model has calculated precision, recall, F1 score, and MAP, which means mean average precision. These will help us to evaluate the uh, precision of how our model is working to detect the safety equipment detection. And it also analyzes the confusion matrices to identify the areas of improvement so that we can improve the safety and safeness levels in our construction sites, which is a very good indicator of how the model is working. And to provide the comfort of detecting the analyzing and understanding the detection of safety equipment, I have also used rendered bounding boxes over the images to just detect the accuracy of safety equipment. And the model also generated the comparative graphs for training and validation loss trends that I'll show in the coming slides. This image explains us about how the YOLO V8 model works. It's a uh, basically a person comes in front of a system and provide digital identity card, and it scans the employee, and according to the pre-trained model it detects what are the PPE or the other compliance items that he has worn on himself, so that it detects what are there and what are not there, and it'll give us some suggestions as well. It shows us what should be included for the person to minimize the risk. These are the visual class distribution graphs for all the 10 categories for training, validation, and testing sets. Coming to the results of my project, um, the, the highlights are that the project is very effective in identifying PPE and non-compliance safety measures such as hard hat, safety vest, and cones, machinery detecting the person. And it also helps in real-time detection, demonstrating with bounding boxes, robust performance across varying environmental conditions such as lighting, angles, as well as some diverse conditions which helps us in analyzing different kinds of situations and images. So the output images is annotated with detected safety equipment. So it basically says which is missing, which what are the items that are missing on a person to ensure safety, such as hard hats, vests. It says the item is missing. So qualitative analysis verify detection accuracy in diverse scenarios will be shown, and it demonstrated the capability to detect the multiple objects simultaneously. So it detects not just one item, but all the items that are we preloaded and trained the model to detect. We can use the model to enhance the site surveillance by identifying unauthorized personnel and also to improve compliance monitoring to prevent accidents and faster incident response through automated alerts, integration with existing safety protocols to ensure seamless adoption, potential for expansion to other industries requiring monitoring safety. These are the output results which we can see that the hard hats, person, machinery, the model detects all of these simultaneously. It detects the safety cones. So all the basic pin categories that I have preloaded the model. So it'll draw a box over the person and detects all the items that we have loaded to the model. These are the sample results my model has provided. The key achievements to the project I have done are developing a robust AI model for real-time safety monitoring, demonstrated YOLO V8 effectiveness in diverse construction scenarios through the diverse data set, and enhanced site safety through automated PPE compliance detection, validated artificial intelligence as a viable tool for improving workplace safety, not just for construction, but in different sectors. The future work that can we can do is to integrate the model with Internet of Things for enhanced monitoring and expansion of data set for broader safety applications, not just in construction, but in different and varied fields. Exploration of hybrid models for improved accuracy and speed of the working of model and development of user-friendly interfaces for real-time monitoring system that we can use directly on the work sites. Thank you. This is my project.